Okay, we are going through the concept of traffic flow theory, and this is what explains how traffic flow operates. Okay, so we have discussed two types of models. One is this one, which is the greenshields model. Okay, which is it has a linear equation, and we derive the equation for the other parameters as well. Okay, where u naught and d naught was the speed and density when you have maximum flow. Okay, capacity. We did the derivation for that, and then we have another model which is called as the Greenberg model. Okay, which is a non-linear model. Okay, and according to this model, the speed is represented with this. The space means speed. And in this model, we have a constant which is c. So we try to find out the value of c using this approach. Okay, again taking the derivative, putting it equal to 0, and in the end we found that c equals to u naught, which is again the speed at capacity, speed at maximum flow. Okay. Now, if you look at this model, okay, this model is for us, right? What was us? Space means speed, right? Okay. So this model is for space means speed, and this model is also for same. Okay. Will both of them give the same answer? This one and this one? Is it possible? No. They are completely different, right? There is no similarity in that. One is linear, the other one is non-linear. Okay? The one is using kj upon k only, and this one is using uf and whatnot. Okay? So both of them cannot give the same answer. Okay? So now I have two equations, both for the same thing, but not giving the same answer. So I have to select, right? I have to select which one to choose. Okay? So this is what they say. The greenshield model, the first one, the linear one. Okay, the greenshield model is more suitable for light to dense traffic conditions. When the traffic is light or medium. Okay, traffic is low or medium. This is where greenshield model, the linear one, works very well. Okay, so basically in this region. Okay. The other model, the non-linear model, it works very well here. Okay, near the chamber. Right? Okay. So yes. Okay. So one is for the left-hand side of the curve, and the other one is for the right-hand side. Okay. The greenshield model, the linear one, is for normal traffic conditions. And the Greenberg model, the non-linear one, the one which has natural log, okay, the second one is for the right hand side. Clear? Okay? Yeah, yes. Okay. Now the thing is, in this model, so we are talking about this one now, the linear one. Okay, the one which works with normal traffic conditions. Okay, light or medium. So in this model now you see there are parameters, right? There is kj, there is uf. Okay, the us will change obviously, but there is k will also change. Okay, but there are some parameters which I don't know. Okay, so I put the value of density, I will get the value of speed. Okay, but there are some constants. There is uf and there is kj. What was the meaning of uf and kj? Preferred speed and which density? Chambers. Good. Okay, so we don't know these values. Okay, so I need some method to find out these values. Otherwise, this equation is useless, right? So we find the constants of this model using the equation of align. You see the equation y equals to a plus b. Equation of a line, right? Remember? Okay, equation of a line. So, in this equation, you must have covered it in statistics. Okay, stat 27 something, right? Okay, you guys also take it, right? So, according to those, according to statistics, if you have an equation of a line, okay, so you need the value of a and b, right? The constants. Okay, just to refresh your memory, what was a? What is a? In the equation of a line, what is a? Slope is this one. Intercept. Okay, so a is intercept and b is slope. Okay, so how do you find out these values? If the equation is for a line, straight line, then these values can be found using these equations. Okay, these values can be found using these equations. Okay, so I will explain these parameters. Okay, now you see here there is a small y here, okay, and there is a small x here. X is the value you will put and y is the output you will get, right? Okay, so x is the input, y is the output. Clear? Okay. So if you take the mean of output minus b, what was b? The slope, into the mean of input. Okay. Now if you look at the equation, what is my input, what is my output? The speed is what? Output. And the input is? Okay, not this one, sorry. This one. The input is? The others are constants. This is the input, okay? So this is the mean of x and this is the mean of y. Clear or not? Clear? Okay. So to get the value of a, I need the mean of output, speed. I need the mean of input, which is density. And I need what? B, which is the slope. Okay. So first I need to calculate the slope. First I need to calculate the slope. And this is the equation to calculate the slope. Okay. Again, x means input, y means output. Okay. So which one is density? X, input. And which one is speed? Y, output. Clear? Okay. Yes. So first of all, you will use this equation, the big one, to calculate the slope. Once you know the slope, you will take the means of these two, you will know, and you will put it by the value of b and you will get a. Clear or not? Any questions? Okay. Now, some important items. First thing is, this equation is what we call as a simple regression equation. Simple regression. Okay, this equation, which you call as equation of a line, okay, or any equation which is in this form, okay, it is called as simple regression equation. Simple linear regression. It's linear, right? Okay. In this equation, the value of y you will get is considered as the mean of y at this value of x. Okay, this equation gives you the mean value of y at this value of x. So I put a value of x, okay, and I will get this much value of y, and whatever value I am getting, I am calling it the mean of y for this value of x. Alright? Clear? Okay. Why? Because we are talking about real world. In real world, you don't get the same value always, right? Huh? So you studied for traffic exam for 2 hours, you got B. You studied for another goes for 2 hours, you got C. Happens, right? Okay, so the same input may not give you the same output. Okay, you may have same input, but the output can go up and down. So the output which the equation is giving you is called as the mean output. Okay, in the language of statistics, it is called as the expected output. The real value could be more or less. Got it or not? They are not. Okay, so that's why we are using mean here. Okay, what did we do here? This equation was y equals a plus bx, right? So to get what? To get a, what they do? Y minus bx. But which y and x mean? Why mean? Because again the reason. Okay, statistics considers that whatever value this equation is giving is the expected value, the mean value. The actual value will be going up and down. Right? This is why we call it the regression. The meaning of it, this is the meaning of regression. That you are always going forward and backward. Okay, this is the meaning of regression. Okay, somebody is doing regression, that means they are going forward and backward. Clear or not? Clear? Done. Clear. Away. Need coffee. No? So this is the first thing. Secondly, now we are saying the y is not the actual y, it is the expected one, right? Mean. So there will be some difference between the actual one and the y of the equation, right? The actual one and the y of the equation. There could be some difference between them, right? The difference could be 0, the difference could be positive, the difference could be negative. Okay. Now let's say the equation gives you y, the density 2. The actual value is 20. The equation gives you 2, the actual is 20. Is this equation useful? No. 2 and 20, 10 times error, right? Okay, 10 times error. So I will remove it. I will not use it, obviously. Okay. The equation gives you 2.1 and the actual is 2. Makes sense, right? I can afford this much. I'll allow this much. Clear or not? Okay. So how do I decide if the equation is very close to the actual amount? Because I'm not talking about single value. I may have 100 values. Okay. In the whole day, how many hours do you have? 24 hours, right? Why are you guys thinking? Yes, on Earth we have 24 hours. Yes. Okay. In 24 hours we can have many values, right? For every half an hour they could be a value. Every 15 minutes they could be a value. The actual number of values could be 100, 200, 300. Okay, even in one day. Okay. So in all these values should I go and check? Okay, this one is 2, this one is 2.1, this one 3, this one is 5.5. Should I go and check every value? It's not possible. Okay. So I have to combine all of them and then check. Okay. So how do we check? We use the R square. Okay. So R square value we call it the coefficient of determination. Coefficient of determination. Okay. Coefficient of determination or the R square is used to check if the equation is close to the actual or not. The output of the equation is close to the actual output or not. Clear? Okay. Now, I'm checking between two things, right? I'm comparing two things. The actual and the equation, right? The actual and the equation. The actual is represented with capital letters here. So you see capital Y and small y, right? Actual is capital. Oh, sorry. No, sorry. Small. We are using small. Small is actual. Small is actual. The equation one is capital. Okay. The small one is actual. The one you are using here, and the capital one is coming from the equation. Okay. So what will happen? You will calculate A and B. Okay, let me give you an example. Calculate A and B. The A comes out to be 3. Let's see. A is 3 and B is minus 2.1. Okay, so my equation is what? Y equals, tell me, 3 minus 2.1 x. Okay, now what will happen? I have values of x and y. Actual values. Okay, I use these values to calculate these A and B. Okay, so there is a value 5, and this one is 20. This one is, let's say, 3.5, and this one is 18. Okay, so I have got these values. Okay, so what will happen? If I put 4 here, I'll get a value of 1. Right? That will be the capital Y for this value of x. What? Capital Y. What is the actual Y? Okay. If I put this value here, the equation may give me, let's say, 19.6. So this will become the capital Y. Okay. And the actual Y is this one. Okay. Then I put the value of x, 3.5. I get another Y. Okay, this is the capital Y at x equals to 3.5. And what is the actual Y here? 18. So at each value of x, after you have the equation, after you got A and B, your equation is complete. Now for every value of x, you have 2 values of y. One is from the equation, the other one is the actual one. Got it? And this is what you are comparing in R square. Got it? Okay, so this is from the equation minus y bar. Bar means what? Mean. Okay, same here. But this is now a small y. So the actual minus mean of actual. Okay, so this was the equation 1 minus the mean of actual. This is the actual 1 minus the mean of actual. Clear? Any questions? All good? Okay. We have got this data. Okay. So the first thing is what we do is we calculate the mean of these two things. Give me the mean. Because we need the mean in all the rows, right? Okay. So give me the mean. You guys have got Excel in this? There's Excel there? So one of you should copy it in Excel. The next one. You will manually take time. Let's put these values into column in Excel. Mean of speed y bar. Okay. 28.9. And mean of density. Okay. So now to calculate B, need these parameters basically. Okay, so like I said, we will not do it manually. So if you can prepare these two columns. Or you can just let me know. Okay, one of you open the table. I'll do it and you can check with me. Okay, so we have speed and density. Give me the values. 53.2, 48.1, 44.8, 40.1, 37.3, 35.2, 34.1, 27, 27.2, 20.4, 17.5, 14.6, 13.9, 13.1, 11.2, 8. Okay, and these values are 20, 27, 35, exactly. Okay. 44, 52, 58, 16, 60. Okay. 64, 70, 75, 82, 90, 100, 1, 5, 15, 115. Okay. So now to calculate B, okay, if I look at the equation of B, I need what? I need the summation of their product, right? I need the summation of their product. So what I will do, I'll go there, I'll do U into K, this into this for all of them, and sum. Okay, so this is the summation of their product. Okay, what else do I need? I need the mean which I already have. Sum upon n is mean, right? Okay, but no, I need to, no. They are sum multiplied by sum divided by n. So I still have to calculate the sum for each one of them. Okay, so sum of this okay, so this one into this one divided by n. How many are they? 1, 4? Okay, so I got this now. I got this one. I need the summation of x squared. So I have to do the summation of x squared. So I will take x squared, which means k squared basically. Okay, so this one, and I need what now? So I did this. Now I need the summation square, then divide by n. So summation of x, which is this one. So this square divided by n. Okay, so I've got all these values now. Okay, so I'll write the equation here directly. Okay, for b. So first of all, I am taking the summation of the product. Summation of the product minus this whole thing. Summation into summation divided by n, which is this one, right? We'll see later on. Then I need the summation of x square, which is this one minus sum square divided by n, which is this one, and this one is yeah, okay. So this is my b value. Okay, this is my b. Okay, so the a was mean of y. So mean of y is this much, 28.9 minus b, which is 0.52, into mean of x, which is 63.7. So how much is a? Minus? Sure. But I have to put the minus with this one. Because this is the minus from the equation, right? So minus. So now how much? Huh? 62. 62. 102. That makes sense. Okay, clear? Any problem? Equation is ready. What was the next question? It's not written here, I'm asking you. I have an equation. I have data. From the data, you need the equation. Okay? Done? This is my final equation. Should I check something? The coefficient determination, right? I need to see if this equation is giving real answers or not. The answer are close to the real ones or not. Okay? So I need two things. I need the actual values. I have the actual value, right? And I need the values from the equation now at each value of x. Okay? So my equation was y equals a plus bx, right? Okay? So now I will replace it. So y is my speed. Okay? And a is 62.02 plus b is minus 0.52. Okay, and x is the density. Clear? Okay. So now this equation will give me the capital Y's for the coefficient of determination. Okay, so I go there. I will call it capital U instead of capital Y. So this is equal to 62.02 minus, because it's plus and minus, so minus 0.52 multiplied by the density. Yes. Okay, so this is, now you can see here I have value from the equation and the actual one. They are not the same, right? Okay. Okay, clear? So these are now capital values, and those are the actual values. Right? Okay. Now what we were doing in the case of y, for coefficient determination, I was taking the difference from the mean of y. Okay. Once with the values of the equation, once with the actual equation. Okay, with the actual values. Okay, so now I'll take the difference. So this minus 28.9, and I'm doing the square. Okay, I'll show you the equation again just to remind you, but I'll show you the equation. So this is the difference with the value of the equation. Okay, and then I do the same with the actual ones. Am I making a mistake? Yeah, 28. Okay, then I will take the sum of both columns. Sum okay, and R square is a ratio of these two values. Okay, I will show you here what I did. Mean, the difference from the equation values. Mean, the difference from the actual values. Both square. Okay, and what is R square? The ratio of their sums. Okay, so this is, if you do the sum, what will you get? It is this upon this. How much? This upon this. How much? Zero point seven. 7. 0.78. Okay. Any questions? No questions? There? Sure? Okay. Now, how do I know that this R square value is good or not? Okay. The best R square value is 1. The best R square value is 1. If you are close to the best, good. Okay. The worst R R square, why we are saying 1 is the best value, meaning whatever is the difference between actual and its mean is the same difference between the equation and the mean. The difference between the actual and the mean and the equation, we are taking this ratio, right? So if these two are equal, the value will be 1, right? So 1 is the best value, okay? So the difference between the mean and the equation is same as the difference between the mean and the actual. Got it? Okay? So the equation is giving you exactly the same difference from the mean. That is good enough. Okay? That is good enough. For statistics, it is good enough. Okay? And 0 means what? How this equation will become 0? How a ratio becomes 0? When this is 0, right? Okay? When this is 0. This will become 0 when? When all these values are equal to mean. Huh? Yes, all these values are equal to 0 plus your grades. Okay? But for the equation, this will become 0 when all y values are equal to y mean. So the equation is not doing anything. It's just giving you one value every time. So that's why 0. Got it? Clear or not? Any questions? Okay, I'm just trying to refresh your concepts related to statistics. Okay, now we did so much here, right? For this question, we spent so much time here, right? Okay, now Excel can do it for you. I'll just show you the function. MATLAB can do it for you. Now remember, the first two columns are my data, right? Others I make them. Okay. Only the first two columns are my data. Okay. So if I only have the data, how do I get the? I go to data. I go to data analysis. You see all these options here? They are available for data analysis, all of them. Okay, maybe you will use them later on or something else. Here I am looking for what? Simple regression. Okay. Regression. Okay. So I go, okay. Now asking for data, y and x. Okay. My y is which value? The speed, right? Okay. I can select the heading as well, so it will give me with the heading. Okay. And my k is this one. Okay, y and x. Because I selected with the heading, so I will tick here. So it will take the first two rows as the headings of the columns. Clear? Okay. And you keep the rest of the things as it is. Okay. The things we have done, it will give you that much. You can look into other options to get more data, get more results. Okay. But this much will be enough. So if I do OK, you can see it creates another sheet. Okay. And in this sheet, you can see the R square value here. Why your R square value is so low? Whatever. Anyways, so you can see the R square here. Okay, and you can see the intercept. The A value. No. The A value, right? Intercept for the A, right? You can see the A value 62.02, 62.55, very close. Okay, you may have done some rounding off. Okay, and the K value is the slope 0.5. Okay, yours was also 0.5, right? Minus 1. Clear now? Okay, so you can get all these results by just one option. Clear? Any questions? The rest of the values you can, look into later on and try to see what are these values and so on. Okay. So what did we do? We had data. Using that data, we made an equation. Then we checked if the equation is good enough or not. And we found it is good enough. Okay. Now we go back. My actual model, according to Greenshield, is this one. Y equals to this minus this into x. This is my actual model. Okay. Y equals to this minus this into x. Clear? Now look at the equation you have got. The equation. US equals to what? US equals to what? Huh? What is the equation? Look at the right hand side. US equals to 62.02, right? So 62.02 is what? Okay. A is UF, right? Clear or not? So my UF is 62.0. UF? No. And UF was what? What was UF? No. What was it? Which is frequency. Okay, so I know frequency now. I know frequency. Okay. Then you look at the equation. The second is this into x, right? This is my x. So how much is this ratio in my equation? 0.5. Okay. So this ratio is equal to 0.5. So UF upon Kj equals to 0.52, and I already know UF. So how much is Kj? How much is it? Yes, K equals what? 119. What was Kj? Jam list. Okay, any questions? Any problem? Clear? You get the data, write the equation, check the equation. If the equation is good enough, you can find out your parameters. And then you can use this equation to find 4 other values. Okay? So for example, do I know from the data, do I know the value of speed when density is 55? Look at the data. Did they give me the speed when density is 55? Do I have it? Not here, okay. Do I have it? No. But now I have the equation. So I can put 55 in the equation, I can get the value. There? Okay, so this is how we use it. Okay. Okay. So now they gave that model directly. This equation which you made, after so much hard work, they already gave it to you. Now they are asking to use the equation now. Okay? So, first thing we need to find out is free flow speed. Free flow speed. Which one was the free flow speed? 62, right? A. Okay, the intercept, right? So this one is very easy, 62. Okay. Now for jam density, what we did in the previous question, we will do the same thing. Okay. So this was 0.51 was the ratio of free flow speed and jam density, right? 0.51 equals to free flow speed, which is 62 upon kj. So how much is kj? 1 to 0.5. Any problem there? Okay. Now, for the rest, we have to do some derivation. Okay, we have to do some derivation. Why? Because you see the next two items are for flow. Do I see flow in the equation which is given? No. Okay, so that's why I need to do some derivation. I have to derive the equation which has flow. Okay, to derive those equations, I'll use this. Where Q is a flow. Okay, where Q is a flow. So, the actual equation is this one. They are asking for density, right? So they are asking for equation between flow and density. Equation between flow and density. So I will replace speed from here. I don't need speed, right? I need flow and density. So the speed will be replaced with this one. Okay? So speed equals to what? Yes, U equals to what? Q over K. Okay. Now I will go to the top equation and replace U as square Q over K. So Q over K 62 minus 0.51 K. And then Q equals 62 K minus 0.51 K square. Any problem? Okay. Now you can see it's a second degree equation. It's a second degree equation, right? Okay. So it's a curve. It's a curve. If you remember last time I showed you these curves. Okay. Maximum flow is which one? This point. Okay. So I have the equation of the curve, second degree equation, and the maximum capacity is the maximum one. What is the slope here? 0. Okay. And if you have the equation, then how do you find out the slope? I have the equation. How do I find out the slope? I do what? We did it last time. Derivative, right? I'll take the derivative. So I'll take the derivative dq dk 62 minus 2 0.51 K. Okay, and the maximum point, the slope equals to 0, right? So I will put it equal to 0. So if this is equal to 0, then K equals to what? 60.7. Clear? Okay. Any questions? So this is the density at maximum flow. How do I know it is maximum flow? Because I make the slope equal to 0. Whatever density you get is called maximum. Okay? Clear? The next they are asking is the speed at maximum flow. You can again do the same derivation like I did for which one? This one. Okay? So you can go back here and replace k now. Because I need the speed and flow, right? I don't need k. So now you can use this equation to replace k from here. Okay? But I don't need to do all this. Okay? I can do a shortcut. Why? Because I already have the equation between speed and density. I already know density. So I can find speed directly. Got it? Okay? So I will put this density over here. The density which is at maximum flow. Remember. Not any density. So if I am putting the density at maximum flow, the speed is also at maximum. Got it? So put density over there and tell me how much is the speed. Yes, 31. Okay, now I need the maximum flow itself. I found the speed at maximum flow, I found density at maximum flow, and what is the maximum flow? What is the value of the flow? Okay, so I have two equations with flow rates, right? Two equations for Q. This one, I can put density here, I will get the maximum. Okay, or this one. I have density and speed both. I can put both of them here, I'll get the maximum flow. Got it? Okay, so how much is the maximum flow? One 1. Clear? Any questions? Any problems? Okay. You will ask me, do we have to remember these equations? No. Will I give these equations? No. We need to remember how did we get it. Okay? Because you see the equation over there, and this is the equation from last question. Are they same? No. Okay? Clear now? This came from data, right? So I may give you one of the equations, the rest we have to work out. Okay? If you go back to the previous lecture, you will see we had an equation to calculate these two directly from these two. So you can calculate these two things from UF and KJ as well. Okay, so we need to remember the relationships. How did we get it? Clear? Any questions? Questions? No? Okay. Yeah. Now the question comes. We did it all for the greenshield model. Greenshield model is a linear model. Okay. So you can easily say, okay, y equals to a plus bx. Okay, and the model looks like this. Okay, so y equals a plus bx. So this is my y, this is my a, this is my b, this is my x. Okay, everything is one to one corresponding, matching, right? Okay, so I can find out everything. But what about this one? The Greenberg model is not linear, right? It's not a line. Okay. So can we use regression for the Greenberg model as well? This is the question. Can I use regression for Greenberg model? Okay. I showed you that the regression is y equals to a plus bx. Does it look like y equals to a plus bx? No. Okay. So I need to do something with the equation if I want to use the regression. Because regression is very easy and common. You can do it using Excel, MATLAB, whatever. Even your calculator will have the function to give you the equation directly. Okay, so regression is very easy and very common. Okay, it's not something new. Okay, so if I can shape this equation in the form of regression, it will become easier for me. Okay, so what do we do? Now we look here. This can be split into two parts. Okay, this is the property of natural log. Okay, anything in the ratio of natural log can be split like this. Okay, so now you see it looks something like y equals to a plus bx. Y, no problem here, right? Anything here, y. Okay, I need a plus bx, right? What is my a? The whole thing, not one parameter, the whole. Okay, so the whole c log of kj equals to a. Clear? Okay, so when you calculate a like we did in the previous example, that a will not be one value, it will be this whole number. Got it? Okay, then we have bx. Okay, now what is my b, what is my x? Tell me. The x is k, the x is k, length. You cannot separate length from the k, right? So the x is length k, okay, log of k. And b is c only. Clear enough? Okay, so you can apply the regression model even to Greenberg equation as well. But your definition of a and b and x will change. Okay, so x is no longer k. X is log of k. Okay. Clear now? Any questions? Okay. Now you see this is the model here. Okay. And this is a Greenberg model, and you have to do the same steps which you did for the previous a. Okay. Now we all know how to use Excel, right? Okay, I will directly go to Excel. You open the values. Okay, this will help you. Okay, tell me the values. You, speed. 100. 20. Speed is 20. Okay, next. 21. 25, 27, 21, 29, 33, 35, 38, 41, 46, 53, 60, 61. Done? Okay, k values 100, 90, 2, 85, 4, 75, 70, 65, 64, 60, 54, 42, 35, 28, 22. Okay, I will show you the initial steps. Okay, and you will calculate the equation, bring it next time. Okay, so then we can look at the other steps. Okay, the first step is my x is not k. My x is log of k, right? Okay, so I still need to calculate the log of k. Okay, so I will do log, yes. Nothing for y, only x. Okay. So now next time you will bring an equation y equals to a plus bx. What is a? What is b? Okay, and you saw the b would be negative, right? To the negative sign. Clear now? Okay, but it will be calculated in the same way, okay, like we did here. For this case, same. Okay, but your x will not mean k. Your x will mean log of k, and your a will not mean uf. Your a will mean c of something. Okay, and your b will not mean this ratio. Your b is cn. Got it? Okay, so next time you bring the equation, also check the r square. Okay, it's very easy now. I showed you from the Excel, right? So just do log of k, use Excel to give you the equation, the intercept and the coefficient and the r square. Clear? Any questions? Any problems? Okay, right on time.